Hello students, welcome back to Diksha Vedantu Foundation channel. So as we all know, your 10th midterm exams are approaching and you are really very busy in the preparation. So to help your preparation, today I have come up with the chapter metals and non-metals. So in this video we are going to complete, like this will be a one shot of metals and non-metals. Like if you study this one video, you will be able to know all the reactions, revise all the reactions, and you will also solving around 20 most important repeated questions which have a high probability of being asked in the exam, right? So yes, now please sit with a notebook and a pen and then write down whatever important reactions and questions we are going to discuss. Okay, so now let's get started without any delay. So now first of all we will see that what is the so now first we'll check what is the classification of matter. Okay, so matters are generally classified like in the terms of pure substance and mixture. Okay, so now in pure substance there is two categories again, elements and compounds. In mixture there is homogeneous mixture and heterogeneous mixture. Now what is element? Element is atoms of same type. Okay, you can see all the green atoms are there. Atoms of same type, when they combine they give you elements. Now what is a compound? A compound means 2 or 3 atoms will combine in a fixed ratio to form a compound. Okay, now the compound, like this is one compound. Okay, so this is one molecule. Okay, so I can say the collection of molecules is called as compounds. Okay, now coming to homogeneous mixture. So in homogeneous mixture, so there will be uniform distribution between the particles. Okay, and in heterogeneous mixture there is no uniform distribution, it will be randomly mixed. Clear? So from here not enough questions are asked, not a very important topic. We'll go to the next one here. Periodic table, I think all of you would have seen. So where these metals and non-metals are exactly present in the periodic table. So here, okay, so there are total 118 elements, out of which 90 metals are there. So generally these all are your metals. Okay, generally there are some around few metalloids are there and 22 non-metals are there. So generally p block elements, if you see carbon, nitrogen, so these all are your non-metals, right? And these all are your metals. So there is more metals in the periodic table. Okay, so now you can see 22 non-metals, few metalloids are there, and I can also now if you see these all elements which are given here, okay, these blue elements, okay, these all are your non-metals. Okay, now coming to next one, if we see, okay, so physical properties of metals and non-metals. So just we'll make a small comparison between their physical properties. So the first one is conduction. So what do you mean by conduction? Means they can conduct electricity. Okay, so metals, yes, they are good conductors. Non-metals, they are not good conductors. Okay, now metals, if we talk about conduction of electricity, okay, conduction of electricity, then metals will also, so when you're talking conduction, it is both electric conductor and heat conductor. Okay, so metals are good conductor, non-metals are not good conductors. Now what is the meaning of ductility? Ductility is a property where the metals can be converted into thin wires. Okay, so yes, metal has the property of ductility, non-metals do not have. Now malleability, what is malleability? Metals can be converted into thin sheets. Okay, sheets, you can see aluminium sheets, you have seen aluminium foil, you have seen, right? So yes, metals can be converted, non-metals cannot. Now coming to luster. Luster means the brightness. Okay, I can say that there will be a shiny appearance of the metals. So yes, metals are generally lustrous. Okay, non-metals are non-lustrous, but there is an exception here, iodine. Okay, iodine is a non-metal but it is lustrous. Okay, next coming to sonority. Sonority means when you hit a metal a sound is produced. So yes, metals show sonority, non-metals do not show. Now density, metals are more dense, right? Metals are more and non-metals are less dense. Now physical state, okay, if you see physical state, metals are generally solid in state. Okay, then non-metals you can find in solid, liquid and gas. Now there is also one exception here, mercury. Okay, we have mercury which is a metal but it is a liquid in the room temperature. Okay, next coming to hardness. Hardness, metals are generally hard. Okay, non-metals are generally soft. Okay, now in hardness there is again an exception, that is sodium and potassium. Sodium and potassium are although metals, but they are very soft and they can be cut with a knife. Okay, now coming to melting point and boiling point. So because metals are there, they have high melting point and boiling point, and here there is low melting point and boiling point. Okay, another exception here also, gallium. Okay, gallium is a metal, okay, but it has very low melting point, that it can even melt at your hand, means the temperature of your palm, with that also the metal can melt. Okay, it has very low melting point. Now coming to some exceptions here are also there. In hardness, non-metals are generally soft, but the exception is diamond here. Okay, diamond is the hardest non-metal known. Okay, it is a non-metal, but it is very hard. And another exception we have here is for conduction, that is graphite. Okay, so graphite is a non-metal, but it is a conductor of electricity. Okay, because of its structure, it can conduct electricity. Okay, so you can remember certain exceptions. Conduction, graphite is there. Lustrous, iodine is there. Then physical state, mercury is there. Then hardness, again sodium, potassium is there. Diamond is there. Melting point and boiling point, gallium is there. Okay, so have you all noted down? So if questions will be asked from here, we have also certain type of questions, I'll show you, but this table you must remember. Okay, next going to chemical properties. Okay, so in metals, how many valence electrons are there? Generally 1, 2 or 3 valence electrons are there, and non-metals have generally 5, 6, 7 valence electrons. Now electron donor or acceptor, so metals are electron donors and these were non-metals are electron acceptors. So if they are electron donors, there will be electropositive. If they are electron acceptors, they are electron negative. Now oxide type, so when metals react with oxygen, they form basic oxides. Okay, when non-metals react with oxygen, they form acidic oxides. Now talking about corrosion, so yes, metals undergo corrosion because they react with oxygen. Here there is no corrosion. Next, type of ion formed. So when metals form ions, they are donating electrons, right? So if they donate electrons, they will get positive charge, so metals form cation. And non-metals, what they are accepting electrons, they are electron acceptors, so if they accept electrons, they will get negative charge, so they will behave as anions. Now coming to reducing and oxidizing agents. Now you see that metals are electron donors, right? Electron donors means what? They lose electron. If they lose electron, what they are undergoing? They are undergoing oxidation. Right? Now the species which undergoes oxidation behaves as a reducing agent. Right? So metals will behave as reducing agent. They will help to reduce others. Now talking about non-metals. Non-metals are what? They are electron acceptors, right? They gain electrons. So if they gain electrons, what will happen? There will be reduction. The species which undergo reduction behaves as an oxidizing agents. Okay, so these are the things that you have to remember in the chemical properties. Next, we'll go to the chemical reactions of the metal. So there are certain reactions that we are going to study. The first one is the displacement reaction. Okay, first reaction of the metals and non-metals is a displacement reaction. Now what happens in a displacement reaction? A more reactive metal displaces a less reactive metal from its solution. Now you can see one example here. See, suppose A is there and BC is there. Now what is happening? A is more reactive than B. Okay, then what will happen? A will replace B from its solution and B will come out. We'll get AC plus B, right? So AC plus B is formed. This is called as displacement reaction. So metals generally shows displacement reaction. Okay, we'll see the examples for that also. Next coming to is the reaction with reactions of metals with water. Okay, so now how does it reacts with water? So see, metals react with water and produce a metal oxide and hydrogen gas. So first metal oxide and hydrogen gas is produced. But what happens? Metal oxides, what happens? These metal oxides are soluble in water and dissolve it in further form metal hydroxide. So metal oxide plus water gets metal hydroxide. So what is the end product that we get? So we get metal plus water. If you take, we will get metal hydroxides. Okay, so metal hydroxides will be forming Okay, the end product is metal hydroxide. Clear? So, okay, now another important thing, all metals do not react with water. Okay, all metals do not react with water. We'll see the reactivity also. Okay, now you see here, this is very important table. Okay, now you see. Okay, one more thing I told you, see. So I can, if I add these two equation, what will happen? I can cancel metal oxide and metal oxide, right? So I'll get metal plus water gives metal hydroxide plus, so here I will not write OH2 because we don't know what is the charge of metal. So we can just put it at X, plus hydrogen gas is produced. Okay, so metal with water will give you metal hydroxides plus hydrogen gas. Okay, now coming to this table is very important. Questions are asked from here. You can highly, there is a high probability of getting questions from here. Okay, so now if you see metals, sodium metals and potassium metals, okay, this one, they are very highly, from this year, every year questions are asked, every year. Sodium and potassium are highly reactive metals. Okay, even with a moisture they can react. Okay, so what happens? We get sodium hydroxide, potassium hydroxide with H2 gases. Okay, next coming to calcium and magnesium. So these cannot, they are not very reactive. Okay, calcium and magnesium like not as reactive as sodium and potassium, but yes, they can react with hot water to give you calcium hydroxide, magnesium hydroxide and hydrogen gases. Next coming to certain metals, right? Zinc, iron, aluminium. Okay, zinc, iron and aluminium, these metals are very less reactive with water, so they react with steam. Okay, they cannot react with cold water or hot water, they require steam to react. So Zn will form ZnO, metal oxide, and this is important, these low reactivity metals do not form hydroxides, do not form hydroxides, they form oxides. Okay, so you can see here there is hydroxides are formed, but for low reactivity metals, they do not form hydroxides, they just form oxides. So zinc will convert to zinc oxide, Fe will convert to iron oxide, aluminium is getting converted to aluminium oxide. Okay, so let us revise this once again. First reaction what we studied, displacement reaction. Second reaction is reaction with water. So sodium potassium can react with cold water to give you sodium hydroxide and potassium hydroxide. Magnesium and you have calcium reacts with hot water to give you calcium hydroxide and magnesium hydroxide plus hydrogen gas. And then three metals, zinc, iron and aluminium, reacts with steam. Okay, their reactivity is very low and they do not produce hydroxides, they produce oxides. Okay, plus hydrogen gas is there. Okay, fine. Next we'll go to the third reaction, that is reactivity of metals. So now reactivity of metals means sodium, so this is the order how the metals are reactive, means I can say that potassium, these metals, potassium, sodium, these are highly reactive metals, and down the group the reactivity decreases, and you have to remember the order. Okay, so remember the order. Okay, now a question may arise, ma'am, how are we going to remember this? So I'll tell you a small mnemonics that you can use. If you have any other mnemonics of your type also you can use, but yes, we will discuss a very simple and very funny mnemonic so that we all can remember this one. Okay, even I forget, but with this mnemonic I have remembered till date the metals order. Okay, so the first one if I tell, okay, K. Okay, so with K we can think some names. Okay, so I think all of you will having some favorite actresses. Okay, so my favorite actress is Katrina, so I'll write it as Katrina. Okay, then for Na I can write Ne. Okay, car, for C I'll make car. Okay, for Mg I can make it as Mangi. I hope all of you are understanding what is this. She asked for a car. Okay, in Hindi the mnemonics is made up of Hindi words, so yes, those who have understanding, that is fine. If you have any other mnemonics also you can comment down and let us make it more interesting. Okay, so now what I'm saying, Katrina ne car mangi. Okay, means Katrina ne car mangi. What are the elements we have used? K, okay, ne, sodium, car, Ca, mangi, Mg. Okay, She asked for car. Now which cars she has asked? Let us name of 3 cars. So that is your Alto, then we can have Zen, okay, and Ferrari. Okay, Katrina ne car मांगी, Alto, Zen, Ferrari. Clear up to this? Let us revise again. Katrina ne car मांगी, Alto, Zen, Ferrari. 7 elements. Okay, potassium, Katrina, ne sodium, car calcium, मांगी Mg. Which 3 cars? Alto, Al, aluminium, Zen, zinc, Ferrari, Fe. Okay, next. Okay, then फिर भी, okay, for PB we have used फिर भी, high, so this high is exclamation, okay, Q, Cu is Q milli. So for Hg we have mercury here, so we'll take a word from M. Q milli silver. For Au, odd. Au is odd. Okay, let us revise it again now. Up to what we have done. Katrina ne car मांगी. Potassium, sodium, calcium, magnesium. Which 3 cars? Alto, aluminium, Zen, zinc, then Ferrari, Fe. फिर भी, Pb, lead, Q, Cu, copper. After lead, okay, फिर भी high, sorry I forgot, फिर भी high is H, okay, Q milli, Cu, M, for M, Q milli, mercury, okay, then silver, odd, silver Ag, odd Au. Okay, I hope now we all have remembered this one. Let us try again. Katrina ne car मांगी. 4 elements, let us first revise. Potassium, sodium, calcium, magnesium. Which 3 cars? Alto, aluminium, Zen, zinc, then Ferrari, Fe. फिर भी, high, so Pb, H, Q milli, copper, mercury. Milli say you have to remember it is mercury, okay. Q milli, silver, odd, Ag, and gold is Au. I hope all of you remembered this one. It's very, very important to remember this mnemonics. If you have anything else you can remember. So this is just a funny way to remember. I hope from today you won't forget this, okay. Fine. Next, coming to reactions of, so now we have done what? First we have done discuss displacement reaction. Second we have discussed reaction with water. Third we have discussed the reactivity order of metals. Reactivity of order of metals we can use in the displacement reactions, okay. Next, fourth one we are going to discuss is reactions of metals and non-metals with oxygen. Okay, so with oxygen what happens? Metals combine with oxygen to form basic oxides. Okay, so you can see copper is a metal, reacts with oxygen to give you copper oxide. Now aluminium oxide and zinc oxide show the properties of both basic as well as acidic oxides. These oxides are known as amphoteric oxides. Okay, so this is very important question here, important one. What is amphoteric oxides? So those oxides which shows the properties of both basic and acidic oxides are called as amphoteric oxides. Now if we see the examples, what do you mean by behave as basic oxides and acidic oxides? That means, see, if you take aluminium oxide, okay, and treat it with HCl, so it is reacting with HCl, so this one is behaving as a basic oxide now, right? It is reacting with an acid, so we will get a salt, that is aluminium chloride and water. Okay, so now if it is a base, right, now this one is behaving as an acid here, right, so here we will get sodium aluminate, that is NaAlO2 and water. Okay, neutralization reaction is happening here. Now next one, non-metals can also form oxides. Okay, so non-metal oxides are generally acidic or can sometimes be neutral also. So you can see carbon plus oxygen gives you carbon dioxide. This is acidic in nature. Okay, so this amphoteric oxides is an important part from where questions have been asked regularly. Next, coming to reactions of metals with dilute acids. Okay, so now you see metals plus dilute acids will give you salt and hydrogen. Okay, so metals in the chapter acids and bases also we have studied that acids reacts with metals to give you salt and hydrogen gas, right? So now hydrogen gas is not evolved when a metal reacts with nitric acid. So in this acid, if you take nitric acid, okay, then we will not get hydrogen gas. What is the reason for that? So now see, HNO3 is a strong oxidizing agent and it oxidizes H2 produced to water and itself get reduced to oxides of nitrogen. So this H2 which is produced here in the presence of HNO3 gets converted to water. Okay, so this H2, if there is HNO3, then it will get converted to water. Okay, now but magnesium and manganese react with very dilute HNO3 to evolve H2 gas. But there are two metals which can react with dilute HNO3 to give you hydrogen gas, and those two metals name is also very important. You must remember magnesium and manganese. Okay, next, metals above hydrogen in the activity series can displace hydrogen from the dilute acids. So now if you see, if we have written the, let us write the reactivity series again. So what we have, Katrina, Ne, Car, Mangi, Alto, Zen, Ferrari, right? Fir B, high. So इसके बाद after this we have Q, okay, Q milli silver Audi, right? Q milli Hg silver Audi. So now what this says that these metals, okay, which are present above the hydrogen, these many metals which are present above the hydrogen, if you take this one with any acids, okay, like for example if you treat K with acid, then you can get hydrogen gas, right? Metals plus acid will give you hydrogen gas, but these elements will not react with acids to give you hydrogen gas. Okay, so suppose I'll say for example Zn plus HCl if I take, so I'll get salt, ZnCl2 plus H2 gas I'll get, right? But if you take these metals, so for example if I take copper plus HCl, then there will be no reaction. So these metals will not react with acids, these metals will react with acids. Again one more thing, if this acid, so now this was about metals, now if this acid is HNO3, then hydrogen gas will not be produced, instead of that we will get water. There are only two metals that can produce hydrogen with HNO3, that is manganese and magnesium. Okay, so that is done for here. So we can see here the reactivity. So you can see potassium, very high reactivity, very violent, very explosive reaction with dilute HCl. Sodium also very high, so I'll write here KNa, Ca, Mg, Zn, Fe, hydrogen, copper, right? So these all elements which are very highly reactive with the metal. So you have to remember these elements react very rapidly with acids, and zinc and iron react slowly, okay, and hydrogen does not react, copper does not react. Okay, so this is also important to remember that copper does not react. Okay, so till now what all reactions we have completed? First we have seen displacement reaction, second we saw reaction with water, third we saw reactivity series, fourth we saw reaction with oxygen, and fifth one we are doing is reaction with dilute acids. Okay, fine. Next, reactions of metals and non-metals among each other, how they are reacting. So metals and non-metals reacts to give you salts. Okay, which salts? These are ionic compounds. Okay, so now what are the properties of ionic compounds? So first of all, how the ionic, like we'll give an example. Suppose NaCl is there, right? So sodium, if you see what is the electronic configuration, it has one valence electron. Sodium has one valence electron, you can set 2, 8 and 1, right? So now what happens? Chlorine has 7 valence electron. There's 7 valence electron. So what happens? Sodium loses 1 electron to get Na plus, and chlorine gains this 1 electron. So I can write this one like this, right? And chlorine gains 1 electron to become Cl minus. Now this Na plus and Cl minus can combine to give you the ionic compound, that is the salt. Now physical nature, what is the physical nature? Here the ionic compounds are generally solid, and somewhat hard because of the strong force of attraction. Okay, next is they have high melting point and boiling point. Solubility, they are easily generally soluble in water but insoluble in solvents such as kerosene and petrol. Next, they are conductors of electricity, but here you have to remember they will conduct electricity only in the molten state, because in molten state ions are produced. Okay, in molten state ions are produced, but whereas in solid state there is no ions produced. So that is why these elements can conduct electricity in the molten state or in the aqueous state. Okay, next, okay, so this is over, reactions part over. Next we'll go to the next topic, how are these metals found in the nature. So metals are like earth's crust, okay, is the major source of metal. Okay, now what is metallurgy? Some terms you need to know. The science, the branch of science which deals with the extraction, properties and purification of metals. Now what is minerals? The elements or the compounds which occur naturally in the earth crust. Okay, so when these metals are occurring naturally in the earth crust, we call them as minerals. Now what are ores? This is very important definition. Now see, those minerals which contain a very high percentage of a particular metal and the metal can be profitably extracted from it are called as ores. Okay, so for example, you have a mineral, okay, suppose we have a bauxite. You know, bauxite is a mineral for ore, aluminium, right? So this is a bauxite. So here some aluminium is present. Okay, so suppose some aluminium is present in a very less amount. Okay, and another bauxite is there. Okay, another bauxite is there. Okay, and here aluminium is present in a very large amount. Okay, so this is also mineral, this is also mineral, but this is an ore and this is not an ore. Why? Because from this mineral metal, the aluminium metal can be extracted more, high yield is there, profitable. But here if you do like if the I can say the operation process charge only is much more and the elements obtained is so less, that cannot be called as an ore. But both of them are minerals because they contain metals in their natural state. Okay, next, gangue particles. So what is this? The impurities present in the ores in the form of sand, soil, etc. are called as your gangue particles. Now enrichment of ore and or concentration of ore. So the process of removal of these gangue particles from ores. So you have to remove, so you can see, suppose, so that means this is your impurities, right? So removal of these and getting these pure metals and then doing its processing is called as enrichment of ore. Okay, fine. Going to the next one. How are these metals extracted from the ores? Okay, so first of all, we found a mineral. From the mineral, we did enrichment of ore and we got the metals. Now it has to be converted in the purest form. Okay, so what is the process involved there? So now you see, if the metal is highly reactive, okay, if the metals are very highly reactive, then electrolysis of molten ore is done and the pure metal is obtained. Okay, so suppose sodium, potassium, very highly reactive metals are there. Just we need to do how to purify them by electrolysis of the molten ore. Next, coming to metals of high reactivity. Okay, so this is very high reactivity, this is moderate reactivity. So if the ore, like see, when there is a mineral is there, okay, suppose this is a mineral and here there is ore, okay, aluminium ore. So aluminium is not present directly in the form of aluminium. It can be present in the form of either carbonates generally or sulfides. Okay, so we need like aluminium carbonate, aluminium sulfate, like this it will be present. So we need to remove these all things, right? So now if carbonate is present, if it is in the form of carbonate, okay, if it is in the form of carbonate, then we do calcination. What is calcination? Heating in the absence of air. Heating in the absence of air. Okay. Now this calcination will convert this carbonate ore to oxide. Okay. So from carbonate what happened? They got converted to oxides. Right. Now if it is a sulfide ore, then we do roasting. What is roasting? Heating in the presence of air. Presence of air. And then we convert this sulfide ores to oxides of metals. Again metal oxides are converted. Then metal oxides will undergo reduction to give you pure metals. Okay, let us revise it again. Metals of very high reactivity, for them it is very simple process. We just do electrolysis and we get pure metals. For metals of high, not very high but high reactivity, for them the ores, the metal is present in two forms, either in the carbonate form or in the sulfide form. If it is carbonate ore, then we do calcination. How can you remember? CC, carbonate calcination. Okay, now this carbonate ores are converted to metal oxides. If it is in sulfide ores, then we do roasting, where we burn it in the presence of oxygen and then we convert it into metal oxides. Now metal oxides gets converted, undergo reduction and gets converted to pure metal. Okay, now if the metal is of very low reactivity metals are generally found in the form of sulfides, then we do roasting and here we get metal and then we do refining of these metals. Okay, so for low reactivity metals, generally they are found in the form of sulfides, and these sulfides undergo roasting and then we convert it into metals and then we refine it. Okay, so you can see here extracting metals of low reactivity in the series. Okay, so the oxides of these metals can be reduced to metals by heating alone. Okay, so like see, what we said, low reactivity metals are found in the form of sulfides, right? So sulfides we do roasting, means heating in the presence of oxygen. So you can see example of HGS is given. This is an ore of mercury. Okay, cinnabar is an ore of mercury. So this is present in the form of sulfide. Now you heat it in the presence of oxygen to get converted to metal oxide, right? Now this cinnabar, that is HGS, directly if you heat also it will get converted to Hg and O2, right? So that is what it is telling, that if you heat, roasting, we can get the pure metal directly by heating. Now if you see for copper, okay, so copper sulfide is there. If you treat it with oxygen, we get copper oxide, and then copper oxide and copper sulfide can react to give you pure copper and sulfur dioxide. Okay, so these reactions are important. Please remember these reactions. Okay, now coming to the next one, refining of metals. So refining of metals, that is your electrolysis method is used. So here you have to remember that this these metals are obtained by electrolytic reduction. These metals have more affinity for oxygen than carbon. Now which metals can be used to refine from this process? Sodium, magnesium and calcium. Okay, and here you have to remember that the impure metal, okay, impure metal is taken as anode, okay, and the pure metal is taken as cathode. Okay, and what are the elements used? Sodium, magnesium and calcium. Okay, next coming to corrosion. I think everybody knows about corrosion. Corrosion means reaction of metals with oxygen. Okay, so now when Fe reacts with oxygen in presence of water, we get rust. When copper reacts with carbon dioxide and hydrogen water, we get bluish green compounds. Silver and sulfur reacts AgS to give you black. These all are your process of corrosion. Okay, so what is the corrosion? Why does it happens? Then what is the consequence? It causes damage and disintegration of the metal. So it generally makes a huge loss of the metals. Okay, so how can we prevent the corrosion? So there are very easy methods. First one is your painting, oiling and greasing. So if you paint, oil or grease, the metals will not come in contact with the oxygen or in the atmosphere and can be prevented from corrosion. Next is chrome plating. So it is a technique of electroplating a thin layer of chromium into a metal object. Okay, next one is anodizing. So here alloying is a very good method of improving the properties of a metal. Corrosion can also be reduced. So alloying means you can just take 2-3 metals and mix it. Okay, now we are going to solve 20 most important questions. I want all of you to answer these questions in the comment section as well. Okay, which of the following oxides of iron would be obtained on the prolonged reaction of iron with steam? So we have seen if iron reacts with steam, we get Fe2O3, right? If you want, we can check once. So yeah, so if you see, iron will give you Fe3O4. Okay, so here we have the correct answer for this question is Fe3O4. Next, aluminium is used for making cooking utensils. Which one of the following properties of aluminium are responsible for the same? So first one is it is a good thermal conductivity. Yes, because it is a metal, good conductor of heat. Electrical conductivity we don't require for cooking. Ductility is not required for cooking. High melting point, yes, this is correct, because if it is not having high melting point, the container itself will start melting, right, and it may react with the food also. So which are the factors responsible for this? 1 and 4. Okay, so correct answer is option number D. Next, what happens when a pellet of sodium is dropped in water? So just now we have discussed that sodium are highly reactive metals. They can even react with cold water, right? So there is a huge amount of heat is generated. It catches fire. Okay, but we have also discussed when metals react with oxygen, they end up with formation of hydroxides. So that catches fire is there. This is not there, this is not there. It catches fire, that is correct. Forms oxide? No, it forms hydroxide. So correct answer is option number C. Okay. Next one. In nature, so these are all your now 2-marker questions that can be asked from this particular chapter. In nature, aluminium is found in the form of compounds while gold is found in the free state. Give reason. So first you have to write why aluminium is found in in compound form. We can write aluminium is more reactive. Okay, so because it is more reactive, it reacts with different compounds and are existing in, reacts with oxygen, carbon, carbonates, and remain in the form of compounds. Whereas gold, you can write gold is very less reactive, right? So it doesn't form any compounds. If it is very less reactive, it doesn't form any compounds, and that is why it is available in the free state. Okay, just 2 points you need to write, you can get 2 marks. Next, explain why calcium metal after reacting with water starts floating on its surface. Write the reaction involved. Okay, so first of all, if we write the reaction, calcium reacting with water, so we have seen that it gives you hydroxide and H2 gas. So we will get calcium hydroxide plus H2 gas, right? So now what happens, if we can just see and balance this reaction, we have 2 oxygen, and so I can just write it like this. Okay, calcium, calcium. So we have 4 hydrogen, 2 oxygen, 2 oxygen. Okay, so now what happens is when this one is formed, okay, you have a, now this hydrogen gas, okay, this comes out as a bubble. Okay, so now what happens, this calcium sticks to this, or this bubbles stick to the calcium. So when these bubbles come out, the calcium sticked on it also comes out, and it seems that the calcium is floating. Okay, so you can write down here the answer. The calcium sticks to hydrogen bubbles, okay, which floats upwards, which we can write down. Okay, okay, which moves forward. 1 second. Yeah, which moves. Okay, which moves. Just a second. Okay, now fine. So which moves forward, or you can which moves towards the top of the test tube, if you are doing in a test tube or something, and it seems that calcium is floating. Okay, so just the answer here is calcium sticks to the hydrogen bubbles, and this is 1 mark, and the reaction if you write, that is 1 mark, right? Okay, next, ionic compounds conduct electricity in molten state but not in solid state. Why? So this is also a 2-mark question. First of all, you need to write that for conducting electricity what is required. Okay, so you can write down electricity is conducted by ions or free electrons, right? Now, when ionic compounds are present in the mold, so ionic compounds forms ionic compounds form ions in the molten state. Okay, that is why it conducts electricity, it conducts in the molten state. Okay, done. That much you have to write. Okay, because in the solid state there is no ions formed, so it cannot conduct in the solid state. Okay, next, what happens to potassium and sodium if it is kept in open? Why are they immersed in what? Kerosene oil. So first point you should write, sodium and potassium are highly reactive. Okay, are highly reactive. They react with moisture. Okay, they react with moisture and catches fire. Catches fire, right? So next point you can write, it is stored in kerosene. It is stored in kerosene to prevent its contact with moisture. Okay, so yes, you have to write to these points and then you can be awarded 2 marks for this question. Next, okay, reverse the following chemical reaction. Reverse of the chemical reaction is not possible, justify the statement. So if I reverse this reaction, what I'll get? Copper plus zinc sulfate is giving me zinc plus copper sulfate, right? So now the statement is said that this reaction is not possible. What is the reason? So now first of all, so what is this reaction? Actually, if you see, this zinc is replaced with copper. So this is your can say displacement reaction, right? And I told you for displacement reaction, it is very important to remember the reactivity order of the metals. So let us revise. So first we have this in Katrina, Ne, right? Car, Mangi, right? Which 3 cars? Aluminium, that is your Alto, Zen, Ferrari. Okay, फिर भी high Q, Milli, Mercury, Silver, Audi, right? Now if you see here what I am saying, that copper displaces zinc. In this reaction what is happening? Copper is displacing zinc. That means what? Copper should be more reactive than zinc, right? Copper should be more reactive than zinc. But if you see that zinc is more reactive than copper, but zinc is more reactive than copper, so that is why copper cannot displace zinc. Copper cannot displace zinc. So this reaction does not happen. Okay, let us see the next question here. Give reason why copper is used to make hot water tanks and not steel. So what are the properties of copper that makes this happen? So first you can write, copper is a good conductor of heat. Okay, so it is a good conductor of heat. And the next one is, it is not reactive. Okay, it doesn't react with water. Okay, so that is why these 2 things helps the so with these 2 properties, copper is used to make this hot water tanks. Okay, next, state 2 ways of preventing rusting of iron. Very easy question. First one you can write down painting, right? Painting, greasing, anything. Second one you can write down galvanization, right? Galvanization is also a very effective tool. What happens in galvanization? Iron is coated with zinc. Iron is coated using zinc. Okay, next, give reasons. Platinum, gold and silver are used to make jewelry. So the main reason for that is they are non-reactive, right? They do not react with anything, so that is why their their shininess, their appearance remains like that for a longer period of time. Okay, if you make jewelries of iron, what will happen? Immediately within a few time it will get rusted, right? So that is why copper, silver and gold is preferred. Second one, sodium, potassium and lithium are stored under oil. Why? Because they are very reactive and they can easily catches fire, right? Next one, if you see, aluminium is a highly reactive metal, yet it is used to make utensils for cooking. Yes, so what is the reason for that? Because it is a good conductor of heat. Okay, it is a good conductor of heat, right? So that is why it is used to make cooking utensils. Okay, next, name the following. So a non-metal that is lustrous, this I told you, it is iodine, right? A metal that is liquid at room temperature, so this is mercury. An allotrope of carbon that conducts electricity, that is graphite, right? So these questions are there from the exceptions part, right? So very, very important to remember the exceptions. Next, a metal M forms an oxide. So now we have come to, okay, so we have already done 2 marker questions, now some 3 marker questions. A metal M forms an oxide having the formula M2O3. Now it is dissolved both in dilute sulfuric acid and dilute sodium hydroxide. So means what? It is an amphoteric oxide, right? Reacts with both sodium hydroxide and sulfuric acid. Identify the metal, write equations for the reactions involved. So now if you see M2O3, right? So I can write that M was +3 state, oxygen must be 2- state, and then when it got crisscrossed we got M2O3, right? So any amphoteric oxide with +3 charge we know is aluminium oxide, right? And we have also written its reaction. So if you think aluminium Al2O3 reacts with HCl to give you what? It will react with this one to give you dilute sulfuric acid, right? So we will make it sulfuric acid. So that is H2SO4, right? So we will get here, so this is an acid, right? That means aluminium oxide will behave as a base here. So we will get, first we will get is salt, that is aluminium sulfate, Al2SO4 whole 3, and then water will be produced, right? This is the first reaction. Next, aluminium oxide will also react with what? Dilute HCl, sorry, dilute NaOH given, right? So here it will form sodium aluminate, NaAlO2, right, and water. Okay, also do not forget to balance the reactions. Okay, you must balance the reactions. Okay, next question. In the electrolytic refining of metal, what would you take as anode, cathode and electrolyte? So I told you anode should be impure metal, right? Cathode should be pure metal. Electrolyte should be salt of M, right? Which, suppose copper is there, you have to take copper sulfate, copper chloride, any salt of the metal. Okay. Next, define the term. So mineral, what is mineral? Mineral is something which occurs naturally on the earth's surface. Naturally on the earth's surface, right? Naturally on the earth's surface. Ore is what? From where we can extract mineral profitably. Extract metal profitably. Then what is gangue particles? These are the impurities present in ores, or I can say minerals, right? Okay. Next question. A metal M does not liberate hydrogen from acids but react with oxygen to give a black color product. Does not react with acids, I discussed you, the metals below hydrogen in the reactivity series will not react with hydrogen, will not liberate hydrogen from the acid. So this metal is nothing but copper, right? Identify the metal M, that is copper, black color product. So copper reacting with oxygen will give you copper oxide, right? 2CuO. So this is your black color product. Okay. Next, explain the reaction of M with oxygen. Okay. So just you need to write here that copper reacts with oxygen to give you copper oxide, which is black in color. Okay. Next is show the formation of aluminium chloride by the transfer of electrons between the atoms. So if you see aluminium chloride, how many aluminium has 2, 8 and 3, right? So it has 3 valence electrons, and chlorine has 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Now what will happen? This aluminum will donate 1 electron here, 1 electron here and 1 electron here. So what will form? Aluminum 3 plus will form and 3 Cl minus will form, and they will undergo, we will get aluminium chloride, right? Okay, next question. A man went door to door posing as a goldsmith. Okay, he was a goldsmith. He promised to bring back the glitter of the old and dull gold ornaments. An unsuspecting lady gave a set of gold bangles to him, which he dipped in a particular solution. The bangles sparkled like new, but their weight was reduced drastically. The lady was upset, but after a futile argument, the man bet a hasty retreat. Can you play the detective to find out the nature of the solution he had used? So you know there is one solution which can dissolve the gold, right? So what is that solution? That is your aquaresia, right? So aquaresia was used, okay, and what is the concentration of aquaresia? 1:3 HCl and HNO3, right? So when you dipped it, okay, so the upper layer of gold which was dull, that became that got dissolved, okay. So the shining, the inner layers of gold came out now, so the gold started shining, but because some amount of gold was lost, that is why the density decreased, okay. So you have to explain both these things, okay. Next, a metal M forms an oxide having the formula of M2O3. It dissolves both in dilute hydrochloric acid and one second, I think this question has been repeated, right? Okay, sorry. So this was a different question here. Okay, so the question here was, I'll change this. The question here was to write the reaction for copper undergoing corrosion. Copper undergoing corrosion. Okay, let me, one second. Okay, so reaction of copper undergoing corrosion, and then you need to write preventive methods also. Okay, preventive methods. So the reaction here is copper with water, carbon dioxide and oxygen forms copper CuOH2 and CuCO3, and this is a green color compound. Okay, and what are the preventive measures? Preventive measures, as we all know, we can write painting, right, greasing, oiling, and then we can write your galvanization, right, or you can write even alloy formation, okay, anything you can write. Next question. A metal X combines with a non-metal Y by the transfer of electrons to form a compound Z. Which type of compound? So when there is transfer of electrons, it is which type of compound? Ionic compound is formed, right? What can you say about the melting point and boiling point? So melting point and boiling point will be very high because it is ionic compound. Will this compound dissolve in kerosene or petrol? No. Ionic compounds can dissolve in water but not in kerosene and petrol, so it is no. Will this compound be a good conductor of electricity? You can write yes, but. What is but? In aqueous and molten state. Okay, in these two conditions it can conduct electricity. Okay, now coming to the last question here, an element E combines with oxygen to form an oxide E2O, which is a good conductor of electricity. Give the following information. How many electrons will be present in the valence shell of the element E? So if you see here E, okay, O. So here it is O minus 2 and here must be it is plus 1. Then this combination has taken place to give you E2O, right? So one electron has been lost, means there will be only one electron in the valence shell of this particular compound, right? Write the formula of the compound formed when the element combines with chlorine. So if you see E is plus 1 and chlorine is minus 1, right? So what I will get here? ECl, okay? So what will be the formula for this compound? ECl. The atomic number of magnesium is 12 and oxygen is 8. Show the formation of magnesium oxide. So if you want to see the formation of magnesium oxide, what is the oxidation, what is the number of valence electrons of magnesium? 2. Oxygen, if you see 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. So what happens now? Magnesium donates 1 electron here and 1 electron here, and we get here Mg2 plus and we get 2O minus, right? Sorry. Yeah, 2O minus we get. So now when they two combine, we get magnesium oxide, right? Okay, so the compound here formed is, okay, formation of NGO we have shown. Name two metals which react with dilute HNO3. So this I have told you, there are two metals, magnesium and manganese, which can produce hydrogen gas from dilute HNO3. Okay, so one more. Okay, now this is your homework question. So we have discussed the most repeated, most important 20 questions from this chapter. I hope you would have answered all of this, and if you have not known some answers, you have got their answers also. Now here is a homework. You have to practice these 3 questions, you have to write these 3 answers, and then we will be discussing these answers in the next class. Okay, so dear students, now we are done with this chapter. One shot of non-metals and metals we have covered with 20 important questions. I hope you would have enjoyed this session and you would have learned something new and have practiced a lot of questions. If you have found this video helpful in your midterm preparation, do not forget to subscribe the channel. Thank you and all the very best for your midterm preparation.